I'm going to consider the variation of field uh, field intensity around point mass. Right. So this is the my point mass M. So I'm going to consider about the field intensity around. Around means right hand side and left hand side. Right. So this field intensity is a vector. Right. So it is a force, some force acting on a 1 kilogram mass. Since it is a force, we can say that the field intensity is a vector quantity. So I have to consider the direction when I am considering, right? So I am taking all the forces acting in this direction towards right are positive. All the vectors in towards right direction is a positive vector. Right? So I'm going to draw my axis. This is a sketch, right? I'm going to draw just a sketch. So this axis is my R values. So I'm considering this R is also a displacement, right? Not the distance. I'm considering this as a displacement, right? So the displacement into this direction is positive, and the negative direction it is opposite direction it is a negative. So to find the field intensity at any point, there is a very simple thing you have to do. You have to bring some 1 kilogram mass and check the force acting on it. So we know that the field intensity is a force acting on a 1 kilogram, right? So I have to consider the force acting on 1 kilogram. So I'm going to use Newton's gravitation law, right? We know that F equals G m1 m2 divided by r square. So since we have know our masses, one is simple m, other one is 1 kilogram. I'm going to substitute it, and I'm consider the distance between them as r. So I can write G m m2 is 1 r square. So when we consider the force acting on 1 kilogram, this is the force acting on 1 kilogram, right? So same force acting m and 1 kilogram. So this force I can define as the field intensity, because I found the force acting on 1 kilogram. So the field intensity is Gm divided by r square. So we can find the shape of the graph considering the r squared value, right? When the r is there is no distance between these two masses, r is going to infinity, right? As you can see, when this is going to close to the zero, field intensity value is going to the infinity. When these two particles are between distance between these two particles are infinity, field intensity is going to zero, right? When the r going to zero, field intensity goes to infinity, right? You can think about it again. Then r is going to infinity, then field intensity is going to zero, right? So as you can know, we know that the all forces are attraction force. Then the force is acting towards this. So the this force or a field intensity is a negative one. So we consider force in this direction is positive, but the force acting opposite direction we consider. So I know all the field intensities right side of the mass is a negative field intensity. So I considering these two properties, we can draw the graph of field intensity as this. Consider in the opposite side, so you have to consider in the opposite side. Then as you can see, when I kept the mass 1 kilogram here, same force acting this direction. So this field intensity is as positive, and they also have the same properties as right hand side. So I can draw the graph to the left hand side of the mass as this. These are all curves because of it's vary with the r squared term. It is not linear one. So when something vary with the square terms, it always going to be the curve. So I can draw the graph variation of field intensity around point mass. Right? This is the graph of that. Then we are going to talk about the neutral points. Neutral points is the point where there is no force acting on a mass. When we kept a mass on a neutral point in a gravitational field, there is no force acting on that mass. So points like that we call they are neutral points. So I take simple example and show you what is a neutral point. Think there is a two masses m here, and there is another mass m1. Both distance between them are simple, right? So according to Newton's law, I can draw the forces acting on the m1 mass, right? I'm considering the forces acting on m1 mass. Due to this left hand side mass, there is a force F, and I am going to write it as F1. Due to the right hand side mass, it is F2. I can write F1 as G m m1 divided by r squared, and F2 as G m m1 r squared, right? As you can see, F1 equals to F2. So if the two forces are acting on the same mass with the same magnitude but opposite direction, as you know by the equilibrium, as you know about the equilibrium, this point in no force acting on this mass m1, because f1 f2 are going to be cancelled out. So no force is acting on the m1 mass. So I can say the point, this point is a neutral point. This point is a neutral point. In next video, we are going to talk about planets motion around sun, and mass and density of planet, and some properties of satellites, geostationary satellites. So see you in next video.